Welcome to another Microservices Meetup, this time not in Einsteigkontur, not sponsored by Autoscout, but sponsored by eGym. And Bea will give a short introduction. Yes! Nice place, good beer, no Agostina, Tegernseher. Could be seen as an improvement, but we're on a high level anyway. So please introduce eGym, and then I will introduce Victor.
Okay. Hi guys. Cool that you are here. We are super happy actually to be able to host this huge meetup this time in our crazy big office space. Yeah, there was a slight misunderstanding with the pizza delivery because we ordered family-sized pizza. So yeah, that didn't turn out so good. But there's more beer, so the beer is also pizza, so that should be fine. Yeah, I just wanted to quickly tell you something about eGym. So you know it's not a gym, but we actually manufacture gym hardware. And yeah. So some words why microservices are a super important topic for us, and then yeah, it will go on with the talk. So yeah, about eGym. So it was founded in 2010, and we started with an electronic strength machine, and the first one of these was sold to a gym in 2012. And since then, actually, a crazy lot of stuff has happened. We have our gym machines which operate in a circuit. They are all connected via the eGym cloud, together with the external devices of our partners. And we have a whole lot of other products as well. So we have the fitness app for the users of the gym. We have the train app for the trainers. And everything in regards to actually improving the experience in the gym with the right data at the right time, more or less. So yeah, since 2012, with the first delivery, a lot has changed, and we grew a lot, not only in products and features, but also in people. So I think when I started 2.5 years ago, we were about like 50 people, and today we are like 388. I actually checked today. So. Yeah, you guys, I guess, can all imagine what happened to our monolith in this time. It grew with the company and yeah, became a little monster. So this is actually why microservices are a super important topic for us. The most important part, of course, that our teams are able to build our services very fast and develop and deploy them independently. And also that we can finally scale, and also scale in a speed that matches the speed of the company growth. So yeah, as of today we have quite a lot of services and fancy new microservices operating nicely with our monolith monster. And as this talk is about authentication and authorization, I also want to tell you quickly what we use for that. So our backend services all are doing authentication and also a little authorization with client and server certificates. And we operate our own CA infrastructure for that. Yeah, something to discuss later on if you guys are interested. But we also have OpenID Connect, and some JSON web tokens can also be found. So yeah, quite a bunch. So I'm actually super excited to learn more about that. And feel free, grab more beer after the talk. You can also try out our machines in our gym, which is opposite to this room. And yeah, that's it. Back to you.
Thank you. Before handing over to Victor, I have a small teaser for you. Microservices, bounded context, and domain-driven design fit together. Who knows about domain-driven design? Okay, cool. Who knows about the book Implementing Domain-Driven Design? Okay. Teaser, next week, Monday, not yet announced. Final conversations are going on. Venue is booked. We will have a spontaneous meetup next week, Monday, at Einstein Kultur, I believe to 99.9% probability with Vaughan Vernon, talking about microservices and domain-driven design. And announcement probably this evening or tomorrow, hopefully, if I get the abstract and bio. So just that you save the date on Monday to be there. And now I'm handing over to Victor, as we are also very interested in hearing about authentication and authorization in the microservices world, because there are some new things you need to do. OpenID Connect I already heard, so these are the buzzwords and these are the problems we have to deal with. I'm totally looking forward to your presentation. Thank you.
Thank you very much. Welcome to this meetup. I'm very excited to have you here, guys. I'm very excited to be here. My name is Victor Aque. I'm a co-founder of ForgeRock and currently working on the office of the CTO for ForgeRock. Who has heard about ForgeRock before? Okay, that's good. For those that haven't heard about ForgeRock before, let me tell you a little bit about ForgeRock. So we are a company that is working with digital identities, identity and access management. We produce software. We don't have, for example, an offering on the cloud. So we install our software. You can install it anywhere. We think digital identity is an enabler to grow business. So not only for security, but also to enable businesses. And we coined this concept of identity relationship management. So you probably have heard of identity and access management. The next step is identity relationship management. That has to do with touching customers instead of only the internal users or of an enterprise. We are proudly a European company. We were born in Norway, in Stavanger, of all the places, in 2010. And we moved, or actually our origins come from Sun Microsystems. All the guys that started the company, 5 of us, used to work with Sun Microsystems. When Oracle announced that they were going to buy Sun, we quit. And then we started ForgeRock. Now we have our headquarters in San Francisco, in California. Offices in 10 countries. We are active in over 30 countries. We protect almost 1 billion identities, digital identities. And we have around 750 customers, enterprises, governments, you name it. And we have external investment. Some of the important investors have also put their eyes on us and they have invested in us. And this is very important. 5 guys started and we're still friends, we talk to each other. That's a good sign. So let's come back to the subject of microservices. You already heard that for some companies microservices is very important. And yeah, right, microservices rule, right? Yes. Divide and impera. In the US they have to translate, divide and conquer. That's what the Romans used to do, right? They divide and then conquer. I think a similar story has to do with the microservices. We started with these monolithic applications, and we chop them down, and then everything is happy. Well, except that you can have a bloody battle with your monolith and your microservices. And this is because we always talk about the benefits of microservices. We always see that, okay, it's very good that we can apply any kind of technology. We can write all these microservices in any language. We focus on specific tasks. We have very good modularity. And then everything is loosely coupled. We can deploy independently. That's very nice, right? But there is a cost associated. And that's what sometimes we don't see. And some of the costs is that to deploy all this, it gets more complicated. Like everything is distributed, and distribution has another added cost, which is we need to call services. A service call a service, then another service. We can cascade those calls, and that is translated into performance. So it impacts the performance. So we have to have that in mind when designing these systems and actually measure. Actually, testing becomes also more difficult. Operational complexity. If we're happy as developers creating these microservices, ask your colleagues that are deploying this. Are they happy? Probably not. Because they see that now they have to deploy lots of different things, and they have to be more coordinated. It's a good exercise for them because then they need to learn about continuous delivery, continuous integration. So if you are already there with continuous delivery and continuous integration, then probably these guys are going to say, okay, that's fine, it's just another thing that we have to do. And eventual consistency is another problem, another cost. What does it mean? When you have lots of microservices and you're presenting, for example, a web page or something to your customer or your client, then you don't know what module or what service you're going to hit. And if there is an update in one microservice, you don't know if that is going to be automatically updated into another microservice. Of course, we have the 12-factor that we need to take into account, so applications don't have dependencies, etc. But in real life, we will see sometimes that the page doesn't show all the data. You have to refresh. Sometimes you hit one service, sometimes you hit another service. So we have to take care of that eventual consistency. And that's one of the costs associated. And with the distribution and operational complexity, well, we know that security and identity and access management is another thing that we need to take care of. And it gets more complicated because of that distribution. But this is still very important. The fact that we are using microservices doesn't mean that we don't have to protect these microservices, or we don't have to provide specific services to our users. And you know the security adoption cycle, right? Just add features, add more features to your microservices. Security later, until it's too late. And that probably applies to several other practices. So there is no security without identity, and vice versa. So we have to have in mind, when we start designing our microservices, security and identity. There are two different practices, two different topics, but they intersect at one point. Right? And that intersection is very important. We have to keep it, we have to design it from the very beginning. And it actually gets more complicated nowadays because we don't deal only with users, with human users. Well, human users, we are already very complicated because we have several personas. For example, now I'm presenting to you as a presenter, but sometimes I'm an attendant. Sometimes I'm a shopper. Sometimes I have different roles in my life. And all of these have to do with dealing with different applications and different services. And when we present services that deal with different persona, things get complicated just per se. But now we have also devices and things talking to our services. And then users or humans also need to pair sometimes with these devices. So when we access a service, that service sometimes need to have knowledge not only of the user, but also of the device that the user is using. Talking about, for example, e.g., the devices that you're producing sometimes probably need to be paired, right, with the human. And if you are producing data, you need to know the origin of data, the user, and the device. Because there are some bloody regulations that say that, right? Like the right to be forgotten, the right to have access to the data, to know what data we are producing, etc. Those are good regulations. They are not that bloody, but we have to fulfill them. And in fact, if you look at those regulations, those are a way to also sell trust. So it is important to fulfill them, but I think it's more important that you sell that trust to your customers if you fulfill those regulations. So at the end of the day, everything and everyone has a digital identity. And to get things worse, these services are not monolithic anymore. They are microservices as well. How are you going to solve the identity and access management problem on an environment like this? Are you going to go one by one? I don't think that's a good idea. You need to think on identity as a platform. Instead of thinking that you could just add on the identity and access management in each of these pieces, you're going to have a problem if you do it like that, because then you start to have silos of solutions. And when you want to integrate all that, it becomes a mess. So you better start to think that identity and access management is a platform or a service that all these different type of entities can use. And Okay, this is the commercial part. No, it's even worse nowadays, as I said, because these applications are also now microservices. Each of these microservices can also have an identity, right? And in fact, they do. When we talk from service to service, we need to identify them if we want security in between those calls. On the other side, the devices and things, they also have identities. And if you think about an environment like this, where the internet plays an important role, the internet is not always on, right? Sometimes there are failures. We don't have the password. It just happened, right? We didn't have the right password, or simply there's some failure, and we need to handle situations where we need to operate without the connection to a central platform. In that case, then you also need to think that some parts of your solutions need to be operational in the edge. And in the edge, you can have, for example, also identity and access management. Think on Industry 4.0. These machines talking to other machines. They are always on, they cannot fail. If the internet fails, they continue operating. So we need also a solution. Okay, wrong button. A solution where we have an identity and access management in the edge. When things get again on, it could synchronize with the identity platform. And the same with the microservices. Sometimes you want your identity and access management solution centralized, depending on the type of deployment that you have. But sometimes you will have, for example, some bots that require local services, local identity and access management services. So it would be cool to have something like that. And another thing is that we need to be sure that the security and identity travels from end to end, from the chip to the microservice, going through humans as well. And privacy and consent is also an important thing on the identity and access management space. Again, regulations, again, trust. If you comply with privacy and consent regulations, you are going to have happy customers. But if we think on identities and entities, actually it doesn't stop there. Because there are more identities. When you start to, for example, use a system, you have a machine, you have an operating system, you need to log in. That's one identity, right? Sometimes you use a platform. For example, you use Kubernetes, you use Cloud Foundry, you use different infrastructure as a service platforms. So you also need an identity to get there, to push software, for example. And then on top of that, we have the services that need to provide some functionality to users, devices, things, applications, etc. So we have several layers of identities. Today, we're going to focus on the green square. So we're going to talk about the microservices and the users that deal with those microservices. Users that could be human or inhuman. That sounded very much like Agents of S.H.I.E.L.D. So when we have a monolith application, from the security perspective or identity perspective, you have an entry point, which is something relatively easy to do. When you have microservices, then your attack surface is bigger because there are several points where our application could be attacked. So we need to protect all those gaps. So this error that you see here is actually an opportunity for an attacker. And that means that when a microservice needs to talk to another service, we need to protect that call. Right? And complexity increases. You probably start with a couple of services like this, but then next week, because we have constant or continuous delivery, then we are delivering more services, more microservices. After all, it's very easy to do that, right? When we have microservices, you just add another one, another one, another one, and things could get crazy. And it all starts with a call from a user to a front-end service, and then there is a cascade of calls, right? And then external services are called, and at one point you have something like this. So performance, as I mentioned at the beginning, is very important. Each of these calls have a delay, right? That you need to take into account, and each of these calls need to be also secured. So when we think then about our microservices and we combine the concept of identity then we can logically think that there are several categories of microservices. There are microservices that need to deal with external identities. For example, are exposed to users, to devices and things. We call these the tier 1 service or type of service from the identity perspective. And these require a high level of security because we know that they are very exposed. There is another level of service, internal microservices, that need to know about the identity of the service that is calling that service, but also might need the identity of the original user or original device, right? And then we have a tier 3 kind of service that only cares about identity of services. Probably doesn't care about what user is requesting the service because it's generic. So we have 3 categories. Don't think that these are on a different network. It's just a logical separation. Just think as 3 different concepts or requirements for identity. But that's the way we could define them. So how do we do identity and access management for these microservices? Well, there are several options. And in fact, that's also one of the beauty about microservices, that we have several options to deploy them, right? There is lots of freedom to deploy. The first one is assume the microservices inhabit a secure realm. So our domain is secure, everything is happy. Check, you are in that position. That's the easy one, right? And in fact, there are companies, big companies that operate under this assumption, which is probably okay. They protect maybe only the entrance, certain layer, and then they consider something inside as secure. Well, the second option is you have security gateways, right? Like proxies or a gateway that covers a group of microservices in a realm. And the third option is be paranoid. Everything needs to be protected. Each microservice needs to be protected. Yes, that's what we want. So this is the first option, right? You have your users. Okay, I just keep using the wrong button. And maybe you protect only the tier 1, and then your other tiers are considered secure because you have a perimeter security. But just remember, perimeter security is a concept of the past. Dinosaurs used to use that concept. It doesn't exist anymore, right? When we think about perimeter security, it's just a fallacy, an imagination concept, because everybody can get across a firewall nowadays. So you better think that that's not a good option. Second option is you add identity gateways. So something that protects your microservices, right? And then you enforce authentication and authorization at those levels. Maybe you can combine, for example, you can protect here some microservices directly and then a gateway. And everything needs to go through the gateway. In fact, this is something that platform as a services like Cloud Foundry use. So when you deploy in Cloud Foundry, then you have a gateway that is protecting everything inside. But everything needs to go through that gateway, so it becomes a bottleneck. That's one option. And of course, if you are not using things like Cloud Foundry, but you use your own deployments, different kind of platforms, bare metal, Amazon, you name it, then you can deploy as many gateways as you need. You divide, again, your domains, you protect those domains or those realms, and you can add as many as you want, or as many as you need. And the third option is, then everything needs to be protected. Right? So each microservice, doesn't matter where you call it from, needs to validate that the one that is calling is a trusted service as well, or a trusted entity. So if we come back then to the diagram, who are these guys calling this authentication and authorization layer, or these layers that we put in the microservices? They call probably central identity platform or a local identity and access management platform. So it doesn't matter. Actually, it depends on the deployment, and all of these deployments are valid. Either you want to call a local identity and access management service, or a central identity management service, or a combination of both. Actually, you most probably will have a combination of both. And to protect these microservices, well, just think about, we know this pattern, right? A user calling a service, the user needs to present something, so we can provide a service. We need to authenticate the user, they have to authorize the user. But then we have this guy calling another service, and the only way to protect these services is by following this pattern. We need to ask for something, and that something is a token, usually, right? Did you see the movie The Good, the Bad, and the Ugly? You know this guy? Blondie, right? So Blondie is a target in this case. He knows about tokens. He just shoots tokens. So what we need is we need to present a token when we call a service. And every one of these tokens needs to be validated to then offer that service. If the token presented is valid, that's fine. If the token has expired, then the caller needs to negotiate another token, right? So to get a token, then we need a service that issues tokens. This service is what we call a token issuer service. So the microservice or the entity that needs the token calls the token issuer service. It presents some credentials. What kind of credentials? Could be a client ID and a secret. It could be a certificate. It could be another token, right? It could be whatever. These are credentials. The token issuer service will validate the credentials, and these credentials could be stored in different type of repositories. Right? Think a database, think a directory server, think probably validating a certificate, and then provide a token in response. The token can be signed by the token issuer. This is important because if the issuer is trusted, then he signs, and then we can have a proof that the token issuer issued that token, and then we can use it. But what kind of tokens then are we talking about? Right. There are two kinds of tokens in this world of difference. There are opaque tokens and transparent tokens. So what does that mean? It means that an opaque token is a token that actually doesn't represent or doesn't contain anything that we can see. It has a meaningless content value. It's typically a random string. And it requires a central service to discover what that token is representing. So in this case, we have an O2 access token. Right. Actually, we see here this string. They are different, an access token and a refresh token. It says the type of token that this is a bearer token, and it has an expiration date. And we don't know more about this. If we want to know more about this token, then we need to call a central service, and then that central service will tell us what it means. It's probably saying this token protects a service, and it was issued to a user, for example. That's an opaque token. A transparent token is the one that actually has a meaningful content. And you would say, well, that's not very meaningful, right? It is a transparent token. You just need to use your special site to discover what that means. This is just encoded and signed, right? And you probably see 3 dots there, right? In that token, you see the 3 dots? Yeah, it has a structure. It's typically a JSON web token or a job token, and in this case, there is no need for a central service to validate or introspect the token. Right? That's a good thing, because then it means that we don't have to hit the central service all the time to validate the token and to know what's inside the token. So that's a good thing. And it could be also an access token. Right? And it's also bearer, it expires, and we know what type of token this is. So how do we validate these tokens? Well, it really depends if it's an opaque or if it's a transparent token. If it's a transparent token, then we have a microservice that receives the request together with the token. And if it's transparent, then if this guy has the intelligence and the way to validate the signature, then it can say, okay, this is a valid token and this is the content. You could just unwrap it, and we can have claims in that token. And those claims represent information about the caller, right? To see that, okay, these microservices one have access to access me, yes or no. I could evaluate that. That would be an authorization process, in fact. It would be more than validation. But that's an option. That's when the token is transparent. What happens when it's opaque? Then in that case, we need an external service, which is a token validation service. Usually this token validation service also will have a way to check with the token issuer what kind of information was behind that opaque token. But we can also use it even if the token is transparent. Because maybe we don't want to have our microservices to deal with, for example, keys, public keys or shared secrets to validate signatures. That would be a mess if we want to do that in each microservice, right? So what we can do is delegate that to an external microservice that is doing the token validation. It's specialized in token validation. So now that we have a token, then we can do not only authentication but also authorization. And I actually already mentioned how we could do that with authorization. If this is a transparent token, well, a microservice could do it itself, but we can also use an external service. And it could be a combination. Could be that our validation service calls an external authorization service and says, hey, is this actually authorized to access microservice 2? Then we get a response. Yes, no, maybe. Maybe could mean, yes, you could if you present these additional claims. That's what is called advice in return. And we probably also send the token unwrapped. And then the destination microservice could operate once it has received that information. But another way to use this authorization service could be, okay, I have a microservice, it has already validated the token, but it needs to know if actually what the caller is trying to do is allowed, right? So it calls this authorization service. This authorization service maybe has some policies defined that say, okay, if the subject of the token is Victor or microservice 1 and Victor, then he can access this service and he can do these operations, or he's allowed to do these operations. That would be a very heavy operation, evaluate that kind of policy. So in those cases, it's recommended to have a caching service as well, that then doesn't need to evaluate all the time. We know what happened, we keep a result here, and then next time that we are hit, then we send a result. If something changes, for example, if a policy change, then the cache needs to be wiped out. The policies don't change very often, so hopefully that's a good thing. So how do we do to obtain these tokens? I already mentioned opaque and transparent tokens. So what protocol do we use? And what kind of authorization is possible? Fortunately, there are standards, right? So we have OAuth2, already mentioned OpenID Connect, and job tokens. So these are very well-known standards. We don't need to invent anything new. Well, maybe. Yeah, in fact, these are standards that are evolving all the time. And I'm actually going to talk about one evolution of these standards in a moment. But let's talk a little bit about these protocols. OAuth2, it's actually a second version. That means that the first version was not that good, right? Yeah, it's an evolution, right? Actually, the first version was very good, but it was very complex. It was so complex that nobody used it. But a few people used it, and it was very, very cumbersome to implement. So the second version focused on usability. So this second version is actually a little bit less secure than the first version, but it's more flexible and it's more usable. It has some restrictions. For example, it says if you use OAuth2, then you must use TLS. You need your channel encrypted. You cannot use an unencrypted channel. So that's one of the requirements. O2 is delegated authorization. So it means that, for example, if I'm trying to access a resource, I'm trying to access that beer. I'm the client. You are the resource owner. you own that beer. You can tell me go for another beer. So I cannot access it. So what I would do is I will actually ask you, can I access that resource? And then you decide. You say, well, who are you? Oh, I'm Victor. Okay, do I know you? Maybe if I paid you something, right? But we're exchanging credentials at that point. And then based on that, you said, yeah, you can use my beer. So you give me a token back that I can use to access the beer. That's what actually O2 does. I'm talking to the resource owner. The owner says, okay, yeah, you can access that resource. I use that token to access that resource. Okay? What can I do with that beer? Well, in this case, it has just a few functions. I can drink it. I can throw the bottle to the trash bin. Those are kind of operations that I can do with that beer. Those operations are scopes. Those are the kinds of things I can do with that beer. Right? So that's what O2 says. It's delegated authorization because I have permission to do those scopes, right? And it's enabling me to obtain limited access. He can say, yeah, you can have it, but only when you finish it, then the bottle returns to me. That's fine, I don't want the bottle. And there are several flows and grants to choose from. I just mentioned to you one flow. This was a flow where I have a conversation with the owner, I exchange credentials, I got a token to finally get access to that beer. And these are the different type of flows in O2. Right? And they have a purpose, a specific purpose. For example, what I described just now could be any of these, authorization code or implicit grant. Right? It's typically using web applications, because the user exchanges credentials, receives a code, then uses that code to obtain a token to finally access the resource. The important thing here is that the client and the owner and the resource server, or the service that I'm trying to access, they don't need to share credentials. So I share credentials with one part, and then when accessing the service, I don't give my credentials to the service. That is important. And I'm just simplifying the protocol, but that is more or less what it does. The other flow is the resource owner password. And this means that I'm probably using something that I trust. So I give my credentials directly to that device, for example, and then that device can access a service and can exchange credentials with an authorization server to access a resource. So I trusted the device. That's why I confided my credentials to that device. So that's then typically used in mobile apps. But there is another flow, which is the client credentials. In this case, I am the owner, or I have the right directly over the resource. Right? So I exchange credentials directly with an authorization server, get a token, and then use that token to access a resource directly. So I don't deal with another owner of that service. And this is typical for services and things. So when a service tries to access another service, it talks to an authorization server, gets a token, and then tries to talk to another service. So that's why this flow is used in microservices and Internet of Things. And O2 is a bearer token. So when I got that token, I could use it to access a resource. And there's a good thing there and a bad thing. The good thing is that it's easy to manipulate. The bad thing is that if you steal it from me, then you can use it to access the same resource. That is why it is recommended to use an encrypted channel. It's one of the drawbacks of O2. And lately, an evolution of O2 has implemented what is called a proof of possession. So I need to prove that I actually got that token in good faith, and I negotiated, and I'm actually the real owner of that token. If somebody steals it, they cannot prove that the token was issued to them. That's what is called proof of possession. It adds complexity, but it solves the issue of a bearer token. And OpenID Connect. What is OpenID Connect? It's again an identity layer on top of OAuth2. So it's actually a use of OAuth2, the protocol. And what it does is, besides giving me an access token, it gives me an identity token, or an ID token. So I actually get two tokens. It's saying, well, yeah, you can access the resource. And by the way, if you are the client, the user that authorized to access that service is this person. So it gives me another token that identifies the user that is trying to access the resource. That identity token, in fact, is a JWT token. I'm going to show you what a JWT token is in a little bit. This is a way to obtain information, basic profile information about the user. And this information is shared only with the client. So if I am the client, I am the only one that I can see that profile information about the user. I mentioned JWT tokens. A JWT token is a way to represent claims in a standard way. So it's actually a JSON, just encoded and signed. So there are other standards around JWT, like JSON Web Signature, JSON Web Encryption, JSON Web Algorithm, and JSON Web Keys. So it's a group of standards to represent a JWT token. And this is a JWT token. I told you, if you use your special site, you can see what's inside. A JSON token has three parts, separated by a dot. The first part is the header. It tells us, okay, this token actually is a JWT token, and it's signed with an algorithm HS256. It's basically saying it's a shared secret. The second part is actually the meat, is the payload. And as you can see here, it's encoded, it's base64 encoded, and then it shows us the claims. This is written. We know who is the subject, or to who this token was issued. It was for subject 1, 2, 3, 4, 5. There are several other claims, like a short name, a name, and there are some standard claims here, like issued at. It tells me when the token was issued, not valid before, it expires at, and this is a Unix time, and the audience that can use this token are these entities. So the audience is a logical representation of the destination. So it means this token can be used only by these three entities. And by the way, this token was issued by this authority. Right? And this is just an additional name. You can add as many claims as you want in a JWT token, which is a good thing and a bad thing as well. Why is a bad thing? Because you can make a JWT token gigantic, and you can choke services. Yeah, I mean, if you are using HTTP, there is a maximum size for the HTTP request and response, and then you can kill the service. You been there? And the final part is the signature. So if you can verify that signature, it means nobody has tampered with that payload. And that's a good thing, because then you are sure that this information is valid, nobody has tampered with it, and everything is cool. So if we combine OAuth2 and OpenID Connect tokens, that's then what we can use in microservices. So what is an access token, what is a refresh token, and what's an ID token? Well, access token and refresh token are used by OAuth2. And the ID token is used by OpenID Connect. Right? Well, the three of them are used by OpenID Connect. So let's see an example of these tokens. This is an OAuth2 token. The first one says, this is your token. It's an opaque token, right? There is a refresh token. You see there is a little difference between these two tokens. What are they? An access token is just telling me, if you present this token, then you might have access to a resource. But this token is going to expire at this time, 599 seconds later. So what do I do to get a new token? I could present new credentials, or I could present a refresh token. The refresh token is used then as a substitute of the credentials to get a new access token. And the scope tells me this is what you can do with the resource that you're trying to access. So it's a kind of permission or authorization. The bad thing here is that scope 1 doesn't tell me if user 1, user 2, or user 3 are authorized to access the resource. So it's missing one thing. It's telling me what kind of operations I can do, but it doesn't tell me what entity can actually access the resource. So it was kind of incomplete Auth2, but it was designed as an authorization service. And here we have just another example of an Auth2 token. Instead of using opaque tokens, it's using transparent tokens. So this actually could be more interesting because then we can add claims here, and those claims could be used to identify users, and it could be used also to authorize the access to the resource. It has scopes as well. I just didn't fit in the screen, but it could have a scope. And this is an OpenID Connect token. As you can see here, an OpenID Connect token has access token, refresh token. This could be opaque or it could be transparent. And it has an ID token. So what it's telling me here is you can use this token to access a resource. And by the way, this was the user that obtained this token. So it's adding the identity part that was missing with the Auth2. Right? There is, however, one thing with the OpenID tokens or the ID tokens. OpenID Connect is used typically in front-end services. Why? Because then we interact with external identities, right? So it tells me what user is trying to access a resource. So it's typically humans. The ID token is addressed to the OpenID Connect client, so the front-end service. So what it's telling me with the audience claim is this token, this ID token, can only be used and actually can only be verified by the client, the front-end service. So I cannot pass that ID token later in the chain of calls. That is a problem, because then I cannot rely that information of the user to the other microservices in the chain of microservice. So what do we do then? If we combine these two, Auth2 and OpenID Connect, then Auth2 uses the scopes to determine authorization rights. As I told you, it doesn't tell me who the user is. But if we combine it with OpenID Connect, then we can have identity information. We still cannot pass it to the backend service. Here is the salvation. The guys from Auth2, they said, okay, we were missing something. Let's add an evolution to Auth2. And it's called the token exchange, Auth2 token exchange standard. It's still not a standard, it's a draft, right? Token exchange 08, it expires on December this year. But what it does is it provides a service or defines a service that says, okay, if you have a user that is calling you and presenting you a token, and it's an ID token, well, that's cool because then you know about the user. But hey, I want to pass that information to the service 3. All right, then if you call the token exchange service, you present that token, you identify yourself, then I will evaluate with an authorization service if you actually can access that microservice 3. So it combines authorization with an STS functionality, and it gives me a new token that probably can change the audience, for example, or the scope, or a combination of both, right? Or you could actually also change the format. It might be that this token is an opaque token, and then I'm getting a JWT token in return, right? It can also be used for delegation. I could say, hey, I want to act on behalf of this user. Could you give me a token that can do that when calling this microservice 3? Yeah, it can do that. I could impersonate as well. I could say, hey, I want to impersonate a user. Maybe I want to impersonate the administrator because there are some tasks that I need to do. Well, if the rules defined in the authorization service allow that, then this token exchange will do that. So there is a dependency on an authorization service, but this is a good thing, that now we have this token exchange to be able to call or pass the identity of a user and a device when calling microservices down in the chain. Okay, so that is one of the salvations. But so far, what are the pros and cons of using O2, OpenID Connect, JWT tokens, opaque, transparent? Well, the opaque tokens are called stateful tokens as well. Right? In this case, the session is stored in a central server, and the tokens must be validated with the central server. These are good when you try to log out. However, there is a price in performance. With a stateful token, you have good security because you cannot inspect. You get the token and you don't see much. But there is a price in performance because then you have to call the central service all the time to validate, to unwrap that token. With stateless tokens, or these transparent tokens, the token may be introspected by the service itself. It can be validated locally. But the difficulty is that you cannot revoke one of these tokens because there is no central store for these tokens. And there is a payable size, right, that we have to be aware of. If we extend that token or make it too big, we're going to choke the server. Right, so those are the pros and cons. And you can decide if you want to validate all the time. You can decide if you want to validate with a central server. But the good thing is that you can use a combination. As I said, if you have an exchange service, then you can take an opaque token that came probably from the users, from the external environment, and then transform it into a transparent token that then can be consumed by microservices down the chain without the need to call a central service. So you get the best of both worlds. Right? So if we come back to the logical view of microservices, then we could say that here we can use opaque tokens, here we can use transparent tokens, and here actually we don't care. We just need to be sure that the tier 2 is able to call the tier 3 service, and it validates that there is authorization for tier 2 to call tier 3 service. So in summary, we need secure interactions between our microservices. Right? We need to be sure that when a microservice calls another microservice, they authenticate with each other. Right? We provide the service if the service is authorized to obtain that service. We need to implement a solution based on standards. We don't need to invent new stuff, but we have to take probably advantage of new things even when they are not yet ratified. Right? For example, what I showed you, the token exchange is version 8 of the draft, but it's not ratified. But there are several companies already using it. Another example of O2 that has not been ratified but is heavily used is something that is called the device flow, and is applied for the Internet of Things. There is no ratification of the standard. Google uses it, BBC uses it, many big companies use it, even when it's not ratified. It works. It doesn't need to be ratified. Be sure that you have or implement an identity and access management solution that you could deploy flexible. So you can have a central and also deployed at the microservice level. And if, for example, you have IoT in place, then you can also use it to authenticate devices and things, and combine also and pair. Be able to relay user thing security or identity to all the services and resources in the chain. Be aware also of the delays in the calls. That's something that you have to measure. You have to evaluate, again, performance and security. There's always that trade-off, right? Performance and security. If you need high performance, maybe you need to give up a little bit of security. But again, there are options. Using a token exchange, you can decide to swap for an opaque to a transparent token. And use standards. Focus on the functionality that you want to provide in your microservice. We saw the adoption of security, right? It's always features, 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 and security is at the end. But you don't have to do that. There are already standards and solutions in place that you can use and simply focus on the functionality that you need to implement. You still probably need to develop some stuff to access these, for example, microservices or identity services that are outside. You could also write those services yourself using these standards. And this is just an example of how could you deploy. You have your users, devices, and things. You might have, for example, a pod of several microservices, and maybe you want all these services locally in that pod. So then this microservice can call the token issuer, gets a token, call the microservice 2, this validates the token, then maybe it needs to exchange the token because it needs information about the user to call a tier 3 service, and at one point we can also evaluate authorization. Not all the time you might be able to use purely these identity and access management services. For example, if you are receiving a token that was issued to a user by an external O2 provider or OpenID provider, maybe your token validation won't be able to validate that. Why not? Let me explain. Token validation is based on signatures, right? I said the issuer signs the token validation needs to validate that signature. If we have access to the public key, for example, to validate, then we can do it. But OpenID Connect is a tricky protocol. OpenID Connect signs the tokens, the ID tokens, with the secret of the client. So with the secret of the client that is interacting with this user. So the front-end service has a client ID and a secret, right? And the response is signed with that secret just for this microservice one. So my token validation service here doesn't have access to the secret, probably, of this microservice, if this microservice was authenticating to an external identity platform. So if it was getting the token from here, that's fine. We have access probably to the secret. But if it was external, we can't do that. In that case, your token validation might need to delegate the validation to the external service. So it can call, that's why it's dotted here. It can call an external service. And the same for the token exchange. The token exchange, for example, as you saw in the diagram, requires of an authorization service. But maybe the rules do not rely only in rules that have to do with this pod, these services and these users of this pod. Maybe there are more extent rules that are stored in an external authorization service, right? So maybe it needs to also talk with an external authorization service. So as long as this identity platform is able to talk in an easy way with these services, that's okay. Typically, if you have a REST interface here, that would be nice. But unfortunately, not all the identity platforms give you a REST interface. But you can use this combination. And you can actually do things very complicated like this. Probably you guys have something like that. Maybe there are companies that will have, for example, regional services with different pods deployed in Docker, Cloud Foundry, Kubernetes, you name it. Actually, it doesn't matter. You don't need to care about that. And maybe you have your local identity and access management services there, microservices like this. But maybe you also have an identity platform providing, for example, federation, more complex access management, more complex identity management, for example, handle the life cycle of users, devices, things, and services. And this could be deployed also in any kind of container as a microservice, probably. Other regions are using different pods. This is a happy story. It's a very complex story, but it is possible. Right? So that's more or less what I wanted to talk to you about. I don't know if you guys have questions. We have good time for questions.